Geo students, welcome to our next video. We're moving on to 8.3. 8.3 is really still using trigonometry. The only difference now, and really you can see it right here, this is something that we may have seen in the last video or in our last set of practice. And then this is a little bit different. And the big difference here is that in this situation I gave you an angle, I gave you one side, and I asked you to find another side. Well, now I'm giving you multiple sides and asking you to work backwards to get the angle. Alright? And so this uses the idea of, you can see it right here, inverse trig functions. Inverse trig functions. Just like if you see addition in an algebra problem, you have to subtract, or just like if you see multiplication in an algebra problem, you know you have to divide, or even the same thing. If you see something being squared, like x squared, you have to square root. Those are all inverse operations of each other. And so now we have to introduce you to the inverse sine, inverse cosine, inverse tangent, etc. Alright? And doing that will allow us to solve right triangles. So, I know I kind of jumped ahead. These are still right triangles, right? So same. I'm going to talk about what's the same in both of these pictures. They're still both right triangles. All right. We know a side. But what is different? The unknowns. And that's the big thing. The unknowns are different. Alright? And so this is what we need to work with today. If we know the sine, the cosine, the tangent of an acute angle measure, don't freak out too much about this. Everything we give you is going to be acute, so don't worry too much about that. If we know the sine, cosine, or tangent, so if we know the ratio, we can use the inverse trig functions to find the measure of the angle. Alright, so again, if we give you the ratio instead of the angle, we have to use inverse trig functions to get the measure of that angle. Alright? Alright. Okay. So, how this will work. Is something like this. Normally, I would give you an angle. I would tell you to take the sine of that angle, and you'd be able to get the ratio. Alright? Well, now we're switching. Now I'm saying we have the ratio, and I need to take the inverse sine of that ratio to get the angle. Alright? If you notice, the spots just kind of flip-flop, right? We rewrite it where our angle and x, or ratio, I guess in this case, switch spots, and of course we had to change from sine to inverse sine. So again, when we talk about inverse cosine, if I give you the cosine ratio, then we can take the inverse cosine of that ratio to get the angle. And then lastly, the same thing works with tangent. If I give you the tangent ratio, you can always use inverse tangent of that ratio to get the angle that you're looking for. Okay? So let's practice some of this now. Maybe if I can get this. Yes, okay. Here we go. So first section is going to be nice and easy. Should just be all in the calculator. This is where you finally get to use your inverse sine or inverse cosine, inverse tangent buttons, which are right above sine, cosine, tangent. So please make sure on these that you hit second and then whatever Is it working? Yeah. Second, and then whichever trig function you're going to use. So in this case, inverse cosine of 0.5 means I need to type inverse or second cosine or inverse cosine of 0.5, and when I hit enter, I get 60 degrees. Alright, please remember, you are going to get a degree measure here because you're taking the inverse cosine of a ratio, which will get you an angle measure. Alright? Now when we use the inverse tangent of 4/5, what happens? We get 38.65. It says round to the nearest degree, so let's go to 39 degrees. And then lastly, this last one is inverse sine. Inverse sine. Or actually, it's not yet. Let's take a look at this. This is a good example here. If I give you that the ratio is 0.94 and we're trying to get the angle, we can always rewrite as inverse sine of the ratio equals angle. Alright, so that was important to write out. Okay, so now I know inverse sine of 0.94 is about 70. Okay, so 70 degrees. Alright, I will let you guys try the next three on your own, and I can go over those answers with you if you want them in class tomorrow. But so now here we go. We're going to find the unknown angle measures. We're going to solve for this triangle. All right, we're going to figure out some missing information. Now, it asks for angle R first. Angle R, if we're talking about angle R, well then I know that 42 is the opposite and 52 is the hypotenuse. Which trig function involves opposite and hypotenuse? The sine. So I know that it is the sine of angle R that will be opposite over hypotenuse. Alright, now we just learned that if we ever have the sine of an unknown angle and we have the ratio, we can always rewrite as the inverse sine of the ratio equals the angle. And that is what I will put into the calculator. Inverse sine of 42 over 52. Notice I didn't even have to reduce that fraction. But when I do that, I get about 54 degrees. For the measure of angle T, I want you to understand that you can do this two ways. The easiest way is for you to understand that because this is a right triangle, I know I can just do 90 minus 54. Alright, if I do 90 minus 54, I should get 36, and that is perfect. Alright, that is more than okay. I'm okay with that. I just want you guys to understand that you could also think about this with trig. Alright, if you are working off of angle T now, well, angle T is here, which changes. This 42 is no longer the opposite side if I'm talking about angle T. It is now the adjacent side, and 52, well, that's still the hypotenuse. So now, if I'm trying to get angle T, and I know the ratio is 42 over 52, I just have to understand that this is not the sine ratio. This is the cosine, Alright, this is the cosine ratio now. And so now I would go ahead and I would take the inverse cosine of the ratio. And when I go to the calculator, I sure hope it's the same thing as what we just got. Oop. Oh, can I do that? Yeah, 42 over 50. 42, 52, 36 degrees. Alright, so again, understanding how right triangles work is more than okay. I thought it was good just to go through this so you understood that you would get the same answer. Now, let's do one more together, because I know these aren't the easiest, and then we will be done. Angle A. If I want angle A, then I need to mark angle A, and I need to say, well, I have the opposite, I have the adjacent. TOA. So I'm going to have to use the tangent of angle A is equal to opposite over adjacent, or 5 over 7.5. And then once again, we've learned that if I have the ratio, I can take the inverse trig function, or inverse tangent in this case, of the ratio to equal the angle. So when I do that on my calculator, let's see here, inverse tangent of 5 over 7.5, 33.6, so let's go to 34 degrees. You guys then should hopefully remember that we can always just subtract from 90, 56 degrees. Of course, just to practice this a little bit more, I do want to go over this and see how it changes the setup of the problem. So now, if I want angle C, what changes? Now the 7.5 becomes the opposite, and the 5 becomes the adjacent. So this is still tangent of C, but I have to say tan of C is equal to the opposite over the adjacent, or 7.5 over 5 now. Alright, so the ratio switched, or reciprocated. And so now, because I'm looking for the angle C, I have to use the inverse tangent of the ratio to get angle C. So, inverse tangent, 7.5 fraction 5, and I get the 56 degrees that I expected. Wait, did we? Yeah, 56 degrees. Alright, so again, all that's really required and necessary is for you to get one angle using trig, and then you can do 90 minus to get the other. I just went through all four to help us practice understanding how to do the setup and how to solve using inverse trig functions. Okay, so that is the video. I think, well, I hope at least that this stuff kind of makes sense, and it's just a little bit extra of a step on top of the trigonometry that you've already been working with. All right, so we will practice this in class. I hope it's making some sense, but of course, please make sure to ask questions if you need to. Have a good one. Peace.